course, this is most known for the Indy 500, but we are waiting for something a little bit special today. With me, I have the 2016 Indianapolis Motor.
The sun plays a huge role in determining the performance of the car based on the track conditions. So we actually, when it's a day like this, as much as it's beautiful for the fans, it's actually very difficult for us as drivers, because as the surface heats up, the oils come to the top of the asphalt and it actually becomes slippier. So that's surprising to people. They think that temperature would mean grip, but it is until a certain point. And then once it kind of crosses over 100 degrees on the surface, you start to actually go the other way.
Wow, and tell me about those tires. How does the sun affect those?
So we use slick tires. So Firestone tires are slick. On a road car, you have tread, right? Because they're supposed to be used in all conditions. Slick tires actually have a bigger contact patch, more surface area, so they generate more grip at a temperature, right? So they operate between 180 to 230 degrees Fahrenheit. Again, the sun is good until a point. When they go over that 230 degree mark, you start to lose that grip again.
Ooh, all right. Well, we have a little competition going on today. We're trying to determine whose big day is it. Is it the sun's, the moon's, or the Earth? So my question to you is, are you Team Sun, Team Moon, or Team Earth?
That's a hard one, but I'm going to go Team Earth. You know, I just think we're so lucky, especially today with the people that are around us here, to be able to witness what we're about to see. Go Earth.
Go Earth. You heard it here first. All right, guys, thanks. We'll be back here. Daryl in Niagara, over to you.
All right, thank you very much, Lauren. Just 500 miles northeast of you, we are here at Niagara Falls, right next to the Niagara River. This is a special location for a lot of people because it is a once-in-a-lifetime opportunity to see a natural wonder set against a celestial one, the solar eclipse. And so let's talk first of all about the natural wonder, and it all starts right here. Look at this massive river and the amount of water that's moving through here. 500,000 gallons of water, 500,000 bathtubs actually going over the falls at every 60 seconds. It's tremendous, the flow here. It interacts with the air, it hits the rocks, and it also, you know, it flows up a mist column that is omnipresent. This is always here. So one of the things that eclipse watchers want to see is, how does it interact with the light? Will we have a pink rainbow because only prominences from the sun will be seen and they're pink? We'll have to see about that. One thing we do need is a little bit better cloud clearing around here, because we do have some cloud cover. But that's okay. People who have gathered here are excited and they're hopeful that it will clear. Who's here? Well, I want to show you our camera from about 500 feet away. Look at all my friendly eclipse watchers. Are you guys ready for an eclipse? Yeah! Well, I love the energy. We could use this energy to blow the clouds out of here. As our camera backs out, you're looking at Terrapin Point, and this is the lawn here. It's roughly the size of a football field, and everybody who's here, a lot of people came in at 6 a.m. this morning. They currently cut off the park from anybody from coming further into Goat Island here. So this is the max capacity that we're at right now. It's that popular. Over to the other side, our friends from Canada. Look across the river gorge, about 1,000 feet away. Niagara Parkway is lined with people. So it's a beautiful shot over there, and we really appreciate our Canadian friends who have joined us. Now, this isn't just about the solar eclipse. We've been here for the past week, and we were at locations all across Niagara Falls.
Well, of course, the main reason we're up here is actually to conduct that science. We maintain the station to keep this platform what it should be, what it was built to be, which is a vibrant laboratory, which covers so many different disciplines on the inside and the outside, like the gravity waves experiment. I mean, it's an honor and a privilege, as much as anything, to have a hand in that science. And we end up being basically the eyes, the hands, the on-site presence to conduct that science. And we get to be the first to see results of just amazing things that are years in the making by a bunch of really smart, ambitious scientific teams on the ground. So that's really where the joy is. Maintaining the station is just like maintaining a research ship, something I actually quite like. So I feel very much at home in that role.
It's still blowing my mind. I mean, we're here in Cleveland, Ohio, live. You guys are up in space in the International Space Station. I can't believe the opportunity that has been afforded to us, and I hope our viewers really enjoyed this time with you. And I hope you enjoy the show from up there. All right.
We have, but we do want to close by saying, first of all, we really enjoy being here, but everybody stay safe and use the simple means to protect your eyes as you look at the eclipse, as Jeanette and I are modeling here, which makes us blind as a bat on the inside, but solar protected on the outside. So we encourage everyone to do the same.
Really great advice from both of
Yes.
them. Thank you so
Thank you
much.
both.
Sarah and I have our glasses
right.
and we're
We are
ready
ready
to go.
too.
Also blind if we don't do this. All right, again, Jeanette, Mike, thank you so much. And we actually have some time to take questions from the audience. We have hashtag Eclipse. That's how you can send questions to us. So let us take a video from another curious kid we have watching.
Hi, my name is Adrian. My question is, why will we not see a total eclipse in California? Thank you.
That's a great question, Adrian. So we only a precious few today are going to get to see a total eclipse because the moon is so much smaller than the Earth. It only casts a very narrow shadow. But still, even in California, you're going to get to see a partial eclipse, and that is still a really cool event. So I do encourage you to get out there and see it for yourself today.
Yeah, absolutely. So again, hashtag Eclipse. Wherever you're watching us, drop that in the comments, and we'll try to get to as many questions as we can on the show. Okay, so we have obviously people celebrating with us online and at events across the country. So why don't we check out some of those events again now? Waco, Texas again. People look very, very comfortable in their camping chairs and spread out on picnic blankets.
They look like they're having a good time.
Yeah.
A few clouds.
A few clouds, but again, they have some time there before. Kennedy Space Center, they will see a partial eclipse. We have some people walking around the Rocket Garden.
Oh, it looks like they have beautiful weather there.
California Academy of Sciences, yes, they do. They have clear skies. We're very, very jealous over here. And then the Mentor Civic Amphitheater that's starting to
fill up.
Exactly. There were fewer people when we checked in ago, but now lots of people there and lots of people at the Adirondack Sky Center. I wish I could wave and say hello.
They look like they're getting ready for some stuff though.
Yeah, absolutely.
They got
Again,
a
the
little time to
snow
wait.
cleared out because
Yeah.
there was snow over the weekend, but now it looks like a beautiful, probably still crisp day there for them. Okay, and now we're back here with astronaut Steve Bone, who's looking around, taking in the sights, Steve. I see.
It's just an amazing amount of people. It's really cool to see.
Yeah,
it's
absolutely.
You can feel the energy.
And it's really
beautiful.
cool that you're here. So Steve is here because, you know, obviously, as we've been saying throughout the show, you really should have these glasses to safely view the eclipse. But if you don't have glasses, that's why Steve is here. So Steve, I see that you brought some supplies for us.
I did, and I have a little bit for everybody, and we'll see how we can do here today.
All right.
So this is like a pinhole viewer, and so it's basically a pinhole camera. I don't know if you ever had to do that when you were a kid. Is make a little camera by basically poking a hole in a piece of paper.
Okay.
And then using that to focus onto a screen.
Okay.
And so we all have pins here, I guess.
Yes. So we have a paper plate. We have index card, and we have pins.
And I have my Crew 6 pin.
Nice, nice. All right, so what do we do, Steve?
Basically, all you have to do is poke a hole in the cardboard.
Okay.
And the sides of the hole will determine the focal length, the focal distance of your viewer.
Okay.
And it has to be big enough that the light will come through. And it's sometimes hard to do if we don't have like direct sunlight. So you want to make sure you have a big enough hole. I think that'd probably be enough.
Yeah.
And then what you'll end up doing, if we had the sun, you could basically over your shoulder, don't look at the sun.
Sun behind us.
Sun behind us.
Yes.
And so you hold this up, and you'll see, you can actually get, there it is. I can see.
We do see it with the lights, the studio lights.
You only need a little bit, and then depending on how far in and out you move it, and the size of the hole, that gives you your focal length.
Got it.
Just like a lens.
And basically, like we're saying with the studio lights, if something were to pass over the studio lights, that same shadow essentially would be would be projected through
Absolutely.
the index card right now. That's how you safely watch it.
That is a good, safe way to watch it. There's a lot of other ways to see it as well.
I know
And,
that.
Oh.
I have that.
Come prepared.
Colander, right?
Yeah. So that's a lot of fun because if you're in an open area like this today, and you don't have your glasses or you just want to see something really cool, again, put it over your shoulder and hold it. You'll get a big array of all those little eclipses happening on the ground below you.
Yeah, actually, I think we have a picture of that. I'd love to see that because really it is a very,
pretty.
perfect. Look at that, Steve.
Oh, yeah.
Well, I mean, even if you don't have anything, right, you can actually use your hands to make your own sort of improvised pinhole camera.
Absolutely. That's amazing. And, you know, I was explaining a little bit ago that in my own yard during the annular eclipse when I was out working in the yard, and I said, "Hey, is there an annular eclipse going on?" So I went under a tree, and I was looking at a tree, and then on my driveway, all these little eclipses, just
Oh, that's
hundreds of them,
amazing. Yeah.
and it's
Beautiful.
absolutely amazing pictures.
Beautiful.
Great. So I hope if
So
people have trees near them, they can take a look at that. Steve, thank you so much
you're
for
very
being here.
welcome.
We really appreciate
Have a
it.
great day.
All right, so the eclipse is getting closer and closer to the west coast of Mexico. We will experience totality there at Mazatlan, in particular, 2:07 p.m. Eastern Time. So let's head back over to James at our eclipse board for another look at the path of totality.
Yeah, thanks so much, Megan. A lot coming up very soon, and make sure you know exactly when to go outside to observe that totality if you're on our path, or even right now, if you're experiencing a partial eclipse. I've got in our Eclipse Explorer here, I can zoom out just a hair here to show you this. I've got our penumbra on, so this is all the places inside here already experiencing a partial eclipse. You've been seeing some great feeds from our camera in Mazatlan, Mexico. They've been experiencing that kind of crescent sun for a little while now. They're just about 20 minutes out from actually experiencing totality itself. They're going to have a long window where they are 4 minutes and 17 seconds. For some context, back in 2017, the last eclipse that swept across America, the longest time was only around 2 minutes and 40 seconds. That was in Carbondale. This time around, some very long times, just a little bit northwest of Torreon, Mexico. They're going to get upwards of 4.5 minutes. A lot of time to really observe it, but just make sure that you know when to be outside. And as always, access that tool at go.nasa.gov/eclipse explorer. This is going to keep moving on. You see this little thing. I have this actually running in real time. This is our shadow of totality. This is going to continue to move further and further to the northeast and actually make landfall in just a few moments in Mazatlan, Mexico. As you've seen all throughout the broadcast, we've got correspondents all up and down the U.S., all the way up to Maine, covering this live. Very excited to continue tracking this. Make sure you know what's going on here. But for now, back to you, Megan.
All right, thank you, James. So now let's introduce you to more of our correspondents along the path, starting first with NASA's Lauren Ward, standing by to show us what's happening in Indianapolis, Indiana.
That's right. Thanks, Megan. We are at the Indianapolis Motor Speedway in Indianapolis, Indiana. It is a gorgeous day. Behind me, I have over 50,000 people here to spectate today. Today, we are waiting for a spectacle that is of a celestial kind. Of course, this is most known for the Indy 500, but we are waiting for something a little bit special today. With me, I have the 2016 Indianapolis Motor Speedway winner, Alexander Rossi. Good to see you.
Good to see you. Thank you so much for having me.
It's great to have you. So the Helio Big Year is a celebration of sun science and how the sun touches everything, including IMS. So tell me, the track when you're doing a qualifying round is about 4 minutes long, which coincidentally is the length of totality. So tell us, what is it like being on the track?
You know what? The sun plays a huge role in determining the performance of the car based on the track conditions. So we actually, when it's a day like this, as much as it's beautiful for the fans, it's actually very difficult for us as drivers because as the surface heats up, the oils come to the top of the asphalt and it actually becomes slippier. So that's surprising to people. They think that temperature would mean grip, but it is until a certain point. And then once it kind of crosses over 100 degrees on the surface, you start to actually go the other way.
Wow. And tell me about those tires. How does the sun affect those?
So we use slick tires. So Firestone tires are slick. On a road car, you have tread, right? Because they're supposed to use in all conditions. Slick tires actually have a bigger contact patch, more surface area, so they generate more grip at a temperature, right? So they operate between 180 to 230 degrees Fahrenheit. Again, the sun is good until a point. When they go over that 230-degree mark, you start to lose that grip again.
Ooh, all right. Well, we have a little competition going on today. We're trying to determine whose big day is it? Is it the sun's, the moon's, or the earth? So my question to you is, are you Team Sun, Team Moon, or Team Earth?
That's a hard one, but I'm going to go Team Earth. You know, I just think we're so lucky, especially today with the people that are around us here to be able to witness what we're about to see. Go Earth.
Go Earth. You heard it here first. All right, guys, thanks. We'll be back here. Daryl in Niagara, over to you.
All right, thank you very much, Lauren. Just 500 miles northeast of you. We are here at Niagara Falls, right next to the Niagara River. This is a special location for a lot of people because it is a once-in-a-lifetime opportunity to see a natural wonder set against a celestial one, the solar eclipse. And so let's talk first of all about the natural wonder. And it all starts right here. Look at this massive river and the amount of water that's moving through here. 500,000 gallons of water, 500,000 bathtubs actually going over the falls at every 60 seconds. It's tremendous, the flow here. It interacts with the air, it hits the rocks, and it also, it flows up a mist column that is omnipresent. This is always here. So one of the things that eclipse watchers want to see is, how does it interact with the light? Will we have a pink rainbow because only prominences from the sun will be seen and they're pink? We'll have to see about that. One thing we do need is a little bit better cloud clearing around here, because we do have some cloud cover. But that's okay. People who have gathered here are excited and they're hopeful that it will clear. Who's here? Well, I want to show you our camera from about 500 feet away. Look at all my friendly eclipse watchers. Are you guys ready for an eclipse? Whoa, I love the energy. We could use this energy to blow the clouds out of here. As our camera backs out, you're looking at Terrapin Point, and this is the lawn here. It's roughly the size of a football field, and everybody who's here, a lot of people came in at 6 a.m. this morning. They currently cut off the park from anybody from coming further into Goat Island here. So this is the max
ECLIPSE's top doctor is encouraging everyone to try and watch the celestial event for our physical and mental well-being.
Hi, everyone. I'm U.S. Surgeon General Dr. Vivek Murthy. I'm thrilled to be joining you today as you gather to experience a truly awe-inspiring event, the last chance that we'll have to see a total solar eclipse in the contiguous United States for the next 20 years. The sun is a universal source of light and life. It contributes to our physical, mental, and emotional well-being, and it unites all of us. Today, no matter where you're watching from, whether it's along the path of totality or a partial solar eclipse, you are sharing the experience with millions across the nation. And moments of connectedness like this truly matter. Last year, I issued a Surgeon General's advisory warning about the public health crisis posed by loneliness and isolation. I shared that our connection with one another is a powerful force that can help protect against the damaging physical and mental health impacts of loneliness. What better reason is there to come together with friends and loved ones than to share a once-in-a-generation experience like the solar eclipse? This is an experience that will stay with you, precisely because of the awe that it inspires. Awe allows us to step outside of ourselves, giving us fresh perspective and opening us up to connections. So grab your eclipse glasses and let's enjoy this moment together.
Some great advice. Thank you so much. All right, we have time for other hashtag Eclipse questions. Sarah, are you ready?
I am absolutely ready.
All right, let's take a look at this video from a familiar face.
Hey everyone, I'm Scarlett Johansson and I play a NASA Public Affairs Director in the new film Fly Me to the Moon. I hope everyone is safely enjoying today's eclipse. I actually have a question about the moon for NASA. So during a total solar eclipse, I've heard that craters and features on the moon play a role in what viewers see on Earth when the moon blocks the sun. So why is that?
Question, Scarlett. So yeah, as we, the moon isn't a smooth marble. It actually has big high mountains and valleys, these craters. And as we approach totality, sometimes you'll hear people talk about Bailey's beads, and these are the last few moments of sun creeping through those deep valleys.
Yeah.
Just before we hit totality.
Yeah. Absolutely. Thank you so much. It's so great to have you here to answer some of these questions, and we plan to take more. If you send them in, hashtag Eclipse again. Okay, if you're just joining us, I'm NASA's Megan Cruz, and this is NASA lunar scientist Sarah Noble. And as you can see, you are watching the official NASA broadcast for today's total solar eclipse. And we are in the heart of downtown Cleveland, where NASA is celebrating this celestial alignment. Take a look at our shot from the air. That is how many people who are just here at the Great Lakes Science Center alone. So many more spread out throughout Cleveland, because again, the last time this city had a total solar eclipse was 1806. But again, just down the road, we have the only NASA center in the path of totality.
When it comes to NASA, I think a lot of people initially think of rocket launches in Cape Canaveral or astronauts floating above the Earth in the International Space Station. But there's a lot of research and engineering and testing that needs to happen before anything can fly. And we have those capabilities: supersonic wind tunnels, microgravity drop towers, vacuum chambers, and a research aircraft hangar. And that's why people from all over the world come to NASA's Glenn Research Center right here in Cleveland, Ohio.
What we work on, power, propulsion, communications, you need it for anything that flies.
We like to say the road to the moon goes through Ohio, and that's because our test facilities are crucial to advancing the Artemis program.
Part of our vision for going back to the moon and establishing a sustainable presence is having a lunar gateway. A lunar space station can fly successfully around the moon and sustain astronauts there. And we are leading the program that's developing the power and propulsion element.
NASA's Neil Armstrong Test Facility in Sandusky, Ohio. It's the only place in the world where you can test a full-size spacecraft for all the extreme conditions of launch and spaceflight.
Right now, we have the Orion spacecraft. This is a spacecraft that actually went around the moon, but we're using it as a test article now to make sure that in the launch environment, that spacecraft is safe.
When it comes to aviation, every U.S. plane has NASA Glenn technology on board, which makes your flight cleaner, safer, and quieter.
And looking at solutions like electric and hybrid electric propulsion systems that will reduce or give us different ways of converting energy that are cleaner.
Our center partners with a lot of community organizations to share NASA's discoveries or just get kids excited about science, engineering, technology, and math.
I really enjoyed the VR experience. It was really cool to be able to sit like I was an actual pilot flying. I feel like I could potentially look into considering aerospace.
We've also made it our mission to prepare Cleveland for the April 8th total solar eclipse.
We demonstrated different types of hands-on activities for educators to share with their students, as well as the science behind a total solar eclipse.
My favorite thing about Glenn is our people. Not only are they crazy smart, but they are genuinely good people. And we are literally part of almost everything NASA does. And so what's really great about being here is you're in the heart of it all.
And joining us live is now NASA Administrator Bill Nelson. So great to have you here for this celestial event. Thumbs up. Thumbs up from the Administrator. Now, Administrator, why are solar eclipses so unique, such a unique opportunity to study our sun?
Because you have the alignment of three celestial bodies, and unique things happen when that occurs. And it has a profound effect here on Earth. Just think about it. The middle of the day, all of a sudden, it gets totally dark. And us Earthlings are not accustomed to that, and nor are the other little Earthlings.
Right.
All the animals. But it's also an opportunity for us to study much more one of those celestial bodies, and that's our star, our sun, and our star in our solar system. And we can find out more about that gaseous explosion that's coming out from the core of the sun when we can see it better. And we can see it better because we're not looking at the bright ball. You're suddenly looking at that corona, that mass of gases that are coming out from the edge of the sun.
Right.
And you don't have to be a scientist, right, to study this event, right? How do we get help from people across the country to help us study these things?
Well, by asking them. Make a note of anything that you observe and then share that with us.
All right, and Administrator, you know, we have to take precautions when viewing a solar eclipse. Remind everyone what we should be doing today.
Okay, you've got some glasses.
That's right.
That's right.
The glasses are
all ready.
Absolutely essential. You want to put these on as it is starting to have that moon move in front of the sun, and we don't want you to damage your eyes.
Right.
Yep.
And it's incredible. You put these glasses on in the normal sun of the day, you can't see a thing.
Can't see a thing.
But when you look at the sun, you will be protected.
Administrator, thank you so much. We really appreciate your time here. And now we're going to head it back over to James at the Eclipse board.
Whew, yeah, the countdown is on. Just a few moments left until the eclipse makes landfall in Mazatlan, Mexico. Right here, you can see where that eclipse totality shadow is right here. It's going to continue moving very rapidly onwards to Torreon, where we also have a live feed covering all of this event. Super excited for that big moment. And let me actually just go to our moon board here, and we can play through this at 60 times speed. I'll zoom in a little bit here. And Scarlett Johansson had a question a bit earlier about the kind of rippling effect that we see of the eclipse shadow. When you first see this right here, at first glance, you might think it's low resolution or lacking some kind of information here. The inverse is actually true. This is actually incredibly high resolution, this shadow projection that we have, because of data that we've been gathering at our moon for more than 10 years, thanks to an orbiter called the Lunar Reconnaissance Orbiter. It's been mapping our nearest neighbor in incredible resolution, just really getting every single bit of valley or crater or mountain. All of those little imperfections on the moon are contributing to that shadow that we see rippling across the country. You're not going to be able to see that from the ground, but looking from space, you see that really cool effect of kind of the rippling there here. So let's just preview some things to come here. In Mazatlan, they have that last little crescent sliver of sun. For now, if you're in that area, make sure you keep your glasses on until that sun is completely blocked out by the moon. That's going to be in just a few moments. You're going to have a long duration there, 4 minutes and 17 seconds. That sounds like a lot of time, but it's going to move like that. So make sure you are ready on the pulse. Again, for all of our locations up on this path of totality here too, make sure you set a timer on your watch or a phone or something to remind yourself to look outside and experience this. You don't want to miss this. If you do miss it, you got a long time to wait for the next big one across America. That's going to be in 2045. So make sure you're watching and watching safely here. You just saw some footage from Kerrville and Cleveland as well. It's a little bit cloudy in some places, really hoping that that clears out in time for us to have that beautiful view. But in just a few moments right here, this eclipse is going to be coming up in Mazatlan, Mexico. So for now, this is going to be really exciting. The countdown is on. So for Mazatlan, this is the last little bit here. Again, I'm always keeping an eye on that weather. And also one little note about our tool here too. If you wanted to see, this little icon kind of previews what the expected eclipse is going to look like at that given time. All these little googly eye features are clickable, hyperlinkable. You can kind of click on that. It'll snap you right to that exact time to get an idea for what it's going to look like in your neck of the woods. But for now, the big moment's coming up. Back to you, Megan. Let's check it out.
All right, thank you, James. And as you can see, wow, we just have a tiny little faint sliver left of the sun in Mazatlan, Mexico. We are expecting totality in 1 minute and 35 seconds. You know, joining us now to walk us through this, Kelly Korrick, an astrophysicist with NASA's Heliophysics Division. Kelly, tell us about the science NASA is about to conduct right now in Mazatlan.
So science that they're going to conduct is about the WB-57. So we're going to fly some planes over and make sure that we can actually see that solar corona, that that hot atmosphere that's around the sun that we're about to get once we reach totality.
Yeah, and it looks like it's
almost there.
Yes, it's almost there. You know, we have a view right now of inside the cockpit of one of the WB-57s, or at least we're efforting one, because as you said, this is going to be a huge part of what we do in Mazatlan.
Definitely, yeah. It's the
there it is,
oh,
Kelly.
there it is. Oh, look at that view.
So we're looking out.
That's great. We're looking out, and it looks like we might be able to, we're seeing a lot of clouds, but hopefully a shadow as well as we're coming in to totality there. And so, yeah, so these WB-57s are carrying 3 different instruments or 3 different experiments, 2 to look at the sun and 1 to look at our atmosphere, because our atmosphere actually responds to the eclipse. And we're trying to figure out how that ionosphere, that layer of the atmosphere, actually responds to it.
And you said it does look like there's already a shadow over land. You know, we also have a shot, and we'd like to pull that up now, a shot of the coast and the fact that it's already going on over. And you know what's really cool about all of this is we do have eyes all over this thing because we are collecting so much data.
Yeah, definitely. I mean, we have the stuff here. We also have rockets on the other side of the country being launched to, again, study that. Oh, look at that. There's the diamond ring.
That's right. We're not there, but I feel the energy just watching it.
Yeah, so this is because of the craters and the peaks and valleys of the moon, we're seeing the last bits that are just getting through, and now we're getting to totality. This is great. So you're starting to see those pink fingers out there kind of sticking out.
Wow. So again, totality here in Mazatlan, Mexico, the first community in North America to experience the moon completely eclipsing the sun. And if you are in Mazatlan right now, it is now safe to remove your eclipse glasses for the next 4 minutes. And you mentioned some of those pink filaments that we're seeing, right? Can you talk us a little bit through that, Kelly?
Yeah. So those pink filaments, because they're helium rich, that's why they're appearing pink and they're hanging out there. Those could be the start of space weather. So there are lots of tons of material, billions of tons of material that could possibly be one of those explosions for space weather. The reasons why we really study the sun and try to understand how to live with the sun.
Well, can you explain why space weather is important to us here on Earth?
Definitely. So it's not just satellites that are interested in space weather. It's also our power grids, because of those energetic particles coming from those big explosions that can happen in the sun. That could damage our power grids. It could also do things like interfere with GPS signals. And I know we all use our phones to navigate everywhere. So if we didn't have that, that would be a big problem. So we're looking to understand it better so we can all mitigate all those things.
Some of the movement we're seeing here is just our telescope operator adjusting, because again, they needed to make some changes for before totality. Now they're viewing it a different way, and then after totality, we might see some shakes there as well. But I really just cannot believe how crisp it is. As we said, it's not a marble, but I mean, just the view of it is so crisp with these little, again, those filaments are just amazing that we can see that to such accuracy, you know?
Right, definitely. And also the white fuzz. I mean, you're seeing something that's 1 million degrees, just hanging out all around the sun. And 3 billion Earths can fit inside of there. So there's a lot of atmosphere there, all around there, just hanging out, being very warm. And so one of our mysteries is, and one of the B-57s are addressing.
There you go, WB-57, our pilot.
Yeah.
He's flying. So basically, Kelly, he is going to fly and try to chase down the shadow for as long as possible, keep up with it as long as possible.
Exactly. The shadow is much faster than the plane. However, they can chase it for a while and get an extra 2 minutes. So on the ground, we can only get 4.5 minutes, and they're going to get 6.5 for that plane.
I love that they're waving to us. Oh, there you go. And now we're flipped. Now we're seeing the front. So again, they are in night. I mean, it looks very dark with only some light on in the horizon. Yeah.
Right. Yeah. And that's what we'll expect wherever we see totality is the night sky is very dark. You might even see some planets or stars. And then you'll see like twilight all around at 360 degrees.
Mm-hmm. What an amazing vantage point as well. My gosh. I'm very jealous. Kelly, are you jealous? I kind of feel like you're jealous.
I'm kind of a little jealous. Yeah, I kind of want to, see if I can make a faster plane so we can, follow it all the whole way.
Plus, they're up above the clouds, so they don't have to worry
about the clouds. Exactly.
Well, I do want to say a big thank you to the WB-57 pilots and the whole team supporting them for that great view. That was awesome. Kelly, you have a wealth of knowledge when it comes to the sun. And for those watching, if you're interested in learning more with her, check out her and other experts featured in the Sun series of NASA's Curious Universe podcast. And that QR code will pop up on the screen, and that'll take you straight to the episodes. Again, look at that double box we got there. We're showing you amazing views during this broadcast. A big thank you, actually, to the Solar System Exploration Research Virtual Institute, or SERVI, for providing the telescope views from Mazatlan.
Yeah, the survey team down there, the survey team is based out of Ames, but it is a collection of teams across the country and across the world that are sort of studying the intersection of science and exploration, helping us get ready for our next trip with humans to the moon.
Yeah, that's amazing. Okay, totality is actually about to end in Mazatlan. Let's keep watching our screen right now for, again, what are we watching for, Kelly?
We're watching for the diamond ring effect. So that's when the first bright light, we're starting to see it on the side there. So you're going to put your glasses on right now to protect those beautiful eyes, because now we're going back to the partial phase.
Whoa, that's amazing.
Wow.
Kelly, that's a filter, by the way, everyone. That's why we're seeing that. But when you said put on your glasses, I'm so trained now to do it that I almost did it here in Cleveland. No, we're fine in Cleveland. We're still in Mazatlan. Again, what we're seeing is because we needed to adjust the filter. Now that, again, it's basically like putting on our glasses. The way that you said people on the ground need to put on our glasses, our telescope operators need to protect their own eyes as well as their equipment.
Exactly.
Well, thank you so much, Kelly. I really appreciate your time here with us. It was so fun to learn about the science and actually see the first eclipse come for North America here. So thank you so much.
Thank you.
All right, as you can see, there's a lot to learn about our sun and eclipses. So to explain it all in a really fun way for kids, NASA developed a clever game called Snap It. We have another QR code coming on your screen right now. Just scan that code, or if you're watching us on your phone, all you have to do is screen grab it, press on it later, and you can check out that game. Also, the website, if that's easier for you, go.nasa.gov/snapit. Okay, so NASA can predict the total solar eclipse's path to a high degree of accuracy because of a spacecraft that launched nearly 15 years ago. This same spacecraft is now helping our Artemis 2 astronauts who'll be orbiting the moon next year. NASA's next step in establishing a long-term presence on the moon is sending 4 astronauts to fly around it with the Artemis 2 mission. Part of the crew's training has been to study images from NASA's Lunar Reconnaissance Orbiter, or LRO. The spacecraft launched in 2009 and continues to use 7 instruments, including a high-resolution camera, to help us learn more about the moon's surface. Because of LRO, we now know more about the moon's topography than any other planetary body in the solar system, including Earth. The Artemis 2 crew used LRO data and photographs to learn how to identify lunar landmarks they'll see from orbit and to seek out sites of scientific interest, like possible landing spots for future explorers. While helpful for planning Artemis missions, people back here on Earth also use LRO to predict the shape of the moon's shadow, or umbra, during total solar eclipses. The moon's shadow will change throughout the eclipse, depending on the lunar terrain and the elevations of observers on Earth. People may even see what looks like an arc of solar diamonds around the moon as sunlight peeks through lunar features like craters. That's a look at your Artemis Moon Minute. All right, joining us on the host desk now is a familiar face here. Oh, actually, sorry, Snoopy. Oh, I just revealed that it's Snoopy. Well, I just want to wave real quick to the crowd here at the Great Lakes Science Center, just outside of our host desk, waving at us, waving at the I'm waving back at them like they can see me. But I did just spoil the surprise. We do have Snoopy here, our chief safety officer here at NASA, and he's here to tell us how to safely watch the eclipse. So, Snoopy, if we were to watch the eclipse today before totality, what should we do? That's right. You should have your glasses on. That's right.
Well, and what about during totality, Snoopy? Can we take them off then? Yeah, let me help you out here.
Oh, Snoopy, there I can see your shining bright eyes. I love Snoopy. He's so funny. Now, Snoopy, I have to ask you a question, okay? So today we've been polling everybody, asking for the total solar eclipse today, who is the big star of the show, right? Is it the Earth? Is it the Earth? Is it the moon? Is it the sun? Okay, but you have to pick one.
You have to pick one.
You have to pick one. You don't want to pick one?
All of them.
All of them are great. That's right. Snoopy, thank you so much. I know you're super excited to see the total solar eclipse today. We're glad to have you here. Bye. All right, now let's head back over to Tahira in Kerrville, Texas.
All right, thanks, Megan. I mean, what an incredible view from Mazatlan, Mexico.
That was amazing.
And folks, as you can see in your screen right now, we are less than 1 minute away from the eclipse crossing over Torreon, Mexico. Gina, how fast is this moon shadow moving right now?
I mean, it's flying. It's going about 1,900 miles per hour as we're chasing it across the U.S.
That is incredible. And so, in Mazatlan, we were able to see the diamond ring effect.
That's right. It was beautiful.
So hopefully we'll be able to see that in Torreon right now.
Yeah, we're watching that live feed.
Yes, just to see this sliver crossing over the moon.
That's right. We're getting so close there.
Hopefully
we'll see that diamond ring too.
Wow. Look at this. And so we're about 10 seconds away.
Here we go.
Let's take it in. Wow. What a spectacular.
Going into totality.
Wow. There you have it. We are in.
Yep, that diamond ring came through, and we see a little bit of those Bailey beads too as we're looking at it. Those kind of the lights trickling through around the surface of the moon, coming through the peaks and valleys.
So what are we viewing on the left-hand side? This almost pink color effect.
Right. And so as we just heard from the last totality, these pink fingers are popping out a little bit. And those are those solar prominences. They're appearing pink because of the helium rich. But we can see it. Let's focus on the corona here, that glow that we're getting. And we can see basically these streams that are coming out, a lot of that energy and brightness that we do not have the ability to see on a day-to-day basis. So with this total eclipse, we're able to see that corona nice and bright coming through in Torreon.
That is just a magical view. Oh my goodness.
It is.
Gina, okay, and so we've got so many questions coming in online right now from viewers watching this. Our first one is going to be from Justin, who wants to know, right now we are seeing a pretty clear and spectacular view of a total solar eclipse.
Yes.
But Justin wants to know, what will it look like if it's clouded over?
Right. So the view that we're getting right now, you won't be able to see that if it's clouded over, but you will have effects going on, right? You'll get a change in the temperature. So the temperature will drop. It'll still get darker as
It's already getting dark here in Kerrville.
I mean, we have some cloud coverage, right? And we're feeling a little extra wind. It's noticeably darker despite the clouds that we have. So you'll get some of those environmental effects, even if it's cloudy where you are.
And so a great follow-up, we've got Halloween Ghoul on YouTube who wants to know, again, will the temperature change during totality? Which I know you mentioned that it will get a little bit cooler.
Yes.
But do you know about how many degrees we can expect?
Yeah, it depends on the location, the humidity, multiple factors, but it can change by about 10 degrees or so, depending where you are, maybe even a little bit more than that. And, we're feeling a little chilly kind of where we're sitting compared to what it was earlier. And I mean, I'm just staring at this view of totality that we have in Torreon.
So we're about halfway through totality right now in Torreon, Mexico. And again, I know folks said that this is almost double totality than 2017, right?
That's right. That's right. And so in 2017, we had a little more than 2 minutes. So we're lucky enough this time that we have over 4 minutes in some places too.
This is so beautiful. And so our next question from Sibel on Instagram wants to know, why is the sun more active right now?
Oh, so the sun is more active because we have an 11-year solar cycle. The sun goes from solar maximum to solar minimum, where it's changing its level of activity. Oh, and as you're seeing the screen, yeah, so I see in that the bottom right there, we can see that prominence extending out. And as we heard earlier in Mazatlan, you know, that is potentially the beginning of space weather activity. So we're talking about solar maximum. If there's a time to see any of that space weather activity during the total solar eclipse, this is the time to do it. So let's watch that as we go through totality in our other locations too, and maybe we'll be lucky to see some of these features change for us.
That is so beautiful.
It is.
And so Gina, too, you know, how we're in a higher cycle, solar cycle right now. How many years, you know, is that fluctuation?
Right. The solar cycle goes on for 11 years when it peaks in activity, and that's where we are. Where the latest predictions are that we will reach that maximum sometime this year, and then it'll decrease in activity going back down to solar minimum.
And so, Gina, I've got time for one more quick question from Christopher on X, who wants to know which other planets have the best eclipses.
Oh, okay. Well, that's right. So eclipses don't only happen on Earth. Let's talk about Mars, for the fact that Mars does have eclipses when the moon crosses in front of Mars. Mars has 2 moons, and the rovers on the surface have captured images of those.
But no other planet has a view quite like this, right?
Nope, that is special for us. Just the distance and the size of the moon makes it such that it will completely block the sun as it's doing today.
Wow.
And you can see there's that diamond ring effect as we are coming out of totality in Torion.
What an incredible
It's a bright one too. Look at that.
That is a bright one. So is this what, a Bailey's bead, or?
So that's going to be that diamond ring, just how bright it is. Bailey beads are a little bit smaller as they kind of bubble over the surface, but folks who are in that location should have those safety viewing glasses back on so that they can now view the partial eclipse that they are experiencing.
Well, that is fantastic. And you know, the next time we see this eclipse, it's going to be right here in Kerrville, Texas. So folks, the countdown is on. We've got about 10 minutes until we see this with our own eyes.
You can hear people
And yes, big moment right here in Kerrville. For now, let's check back in with Lauren at the Indianapolis Motor Speedway.
Thanks to Hira. We are getting close to eclipse ourselves, but for now, we have a very special guest, NASA's very own Pam Melroy, Deputy Administrator and former astronaut. Pam, it's good to see you.
Oh, it's great to be here. I'm so excited.
It's very exciting. So what's it like being in Indianapolis for an exciting event like this?
Well, it's a beautiful day here. And I love the fact that we're here with thousands of people in the Indianapolis Motor Speedway, but we're joining with millions of people around America looking up together to the sky.
Absolutely. And tell me, is this your first eclipse?
It's not my first eclipse, but it will be my first totality. I've seen several partial eclipses, but there's something mystical and mysterious and in some ways unifying about a total eclipse. And we're all going to feel it together.
Absolutely. We could not have lucked out more on this weather today. So as a former astronaut, we know that sun science and space weather are very important to keeping our astronauts safe. What is space weather, and why do we care about it? What is NASA doing to study it?
Yeah, that's right. It's actually very important. It is of concern for astronauts who are in space because they experience the radiation of the sun that comes from solar flares and solar weather. But the reality is it's also affecting life here on Earth. It impacts the upper reaches of our atmosphere called the ionosphere, which is an electrified part of our atmosphere that is a conduit for communications. It's critically important. It can even affect power grids. And of course, if you ever have seen the Northern Lights, you've seen the effect of solar weather. So, but really the focus for today is where that solar weather starts. And that's in the corona, the sun's atmosphere. It's very unusual, and we don't exactly know what's happening because the sun's atmosphere is millions of degrees hotter than the surface of the sun. So we are hoping to learn today more about how that happens and why that happens so that we can better predict those solar flares and those things that impact us here on Earth.
Yeah, that's all extremely important and something that we're learning a lot today, too. Pam, thank you very much for joining us today.
Thank you.
As we've learned, solar eclipses are very important to learn for many, many reasons. We have radio telescope operators who are studying the eclipse today for this very reason. Let's take a look at that work.
When the moon blocks the sun during a solar eclipse, there is a noticeable impact on Earth's upper atmosphere, known as the ionosphere. These changes can affect radio communications, including amateur radio, also known as ham radio.
Ham radio is a way you can talk to people all around the world. You set up a radio and antenna. You talk into the radio sends a signal up to the antenna sends a signal up to the sky. It bounces off of the electrified layer of the sky back down to Earth, where you can talk to the person on the other side.
During the 2024 total solar eclipse, the HAM-SCI Citizen Science Project is inviting ham radio operators to transmit radio signals. The goal is to have people make as many radio contacts as they can with operators in different locations during the celestial event. By recording how strong their radio signals are and how far they go, ham radio operators and scientists can learn about how the ionosphere changes during solar eclipses.
Sometimes you can talk around the world and sometimes you can't. And that's all based on what the ionosphere is doing, what the sun is doing. When it works, when you are able to talk to these faraway places,